Okay, here's video reassessment for the momentum standard. The question I chose was a bobsled has a mass of 1.357 times 10 to the second power kilogram. A constant force is exerted on it for 5.42 seconds. So its initial velocity is 0 and its final velocity is 8.73 meters per second east. So part A asks what is the change in the momentum. So let's see, we have mass is right here, then time, velocity is, initial velocity is 0, final velocity is 8.73 meters per second east. So we need to find the change in momentum. So change in momentum is going to be the mass times the change in velocity. So mass times change in velocity is going to equal mass times the velocity final minus the initial velocity. So we have that right here, and the change is going to equal 1.18 times 10 to the 4th kilogram per meters per second east. So then part B asks to find the net force exerted on it. So here we know that the change in momentum equals the mass times the velocity, and F net is going to equal mass times acceleration. So if you solve this for M, switch it around, it's going to be the mass equals F net over A. And then A is going to equal the delta V over T. And then from there you can say, let's see, that M equals F net over the delta V over T. And then F net times T divides by the change in velocity. If you bring that here, we can see that the change in momentum equals F net times time divided by change in velocity times change in velocity, which these two velocities cancel out to give us the final formula of the change in momentum equaling the F net times time. So once we have that, we can say that this is the final formula that you would solve this one for F net. So F net equals the change in momentum over time. So right here, if you put in the values that we got previously, the change in momentum over the time, you will get the F net is 219 newtons east.